Thank you, Paulo. So in this talk, I want to bring a number of the concepts that we have been working with into the real, if you like, area of health and illness in modern societies, large and small, and show how epidemiology, the field that looks at the distribution of illness, can be related to some of those concepts that arise out of physics and that you and Lucio and others have pioneered. My own contribution has to do with the influence of the economy, basically, and social components of social life, insofar as they are both promoters and include risks to death of the way our society functions. Looking at the first topic, human complexity and innovation, with the idea that complexity originates with innovation. Complexity or development can refer to development in general, without reference to the species or level of society, or other levels of existence, but along the lines of species hierarchy, humans are considered at the highest level and are the most complex. But what is complexity in human society? First of all, it is not measurable in the usual physics equations that describe growth. In those physics equations, complexity can occur within a very, very short time, less than a minute, or as long as a century, or in terms of the whole of evolution biology over millions of years. But in all of these instances, it implies growth and development. But human complexity is categorically different because it requires interaction of subjects that are themselves arranged in hierarchies, where hierarchies is the key term. Complexity in the human case requires a more extensive division of labor in order to fulfill the component requirements of innovation that are the bases, the foundations of the complexity itself. Innovation creates the basis of new developments that promote growth. But those innovations obviously require new types of laborers, of staff, and a new division of labor. The issue of complexity and the human division of labor. Where does this new division of labor come from? It comes from a new hierarchy of functioning, corresponding to emerging technology, which in turn will be the basis of increased production, and most importantly, of productivity. How does the newly required labor organize itself so that this labor force aligns with the emergent new technology? Or shall we say that this new labor organization represents self-organized and perhaps temporal criticality? In a sense, yes, it is self-organized, but how? It is organized through intensive competition. Competition is the foundation. How is this possible? The labor differentiation based on varying skill sets of skills and efforts, attitudes and goals are differently valued, both by industrial organizers of labor and by the society as a whole. A major example, of course, is that formally educated persons are more highly valued than non-educated individuals. The newly, that is, differentially educated and therefore valued individuals now compete among one another for the differentially valued and paid, I should add, and empowered positions that are created by the newly emergent technologies based on discovery and marketing innovation. And the marketing, I refer back to Lucio's previous talk. Of course, skills and so forth theoretically play a crucial role in the new labor distribution. But other factors of affiliation, of linkage, of cooperation, as Lucha referred to it, including region, religion, political party, ethnic heritage, also play distinctive roles. Now the idea of competition in relation to complexity. But this is not the end of the force of competition or the story of competition. The maximum competitive force concerns which innovations will dominate the new technology. The second competitive force concerns which employees will be most closely aligned with the new technology. The labor competition will then determine the newly emerging social class structure, which will now determine the health hierarchy. As usual in our epidemiology, with the highest social class having the best health and the lowest mortality, this positive statistical relationship between health and social class is probably the most powerful in all of epidemiology worldwide. But this is not the end of the competitive situation. The competition continues throughout society, between firms, that is to say, businesses and industries, between regions and political parties, between countries, between ideologies, between ethnic and religious groups, between countries for regional and international domination. In other words, competition is the immediate source of growth, that is, the enabler of growth, it enables growth. However, when competition becomes overly intense, there can be stressful destruction of the losers, from the level of the labor force to firms and industries, and all the way to regions, political parties, and countries. Now the question of crucial events versus harm to society by other types of events. Critical events occur in technological or political terms, in theory, when it is for the betterment of society, but those events are not predictable within the society. But they are essential to economic growth and improvement in societal health. But the world is not so simply comprised of economic developmental enhancement of short or long duration that enhance health. In fact, damaging effects of development and competition may be just as important. And we can look here at the subsequent paper by Professor Iacono, who points these out. May be just as important for poor health and the repair and prevention function of complexity. For example, smoking, high levels of drug use, erroneous events or adverse events in medicine and surgery, climate change, wars, and genocide. Thus, we can say there is another overriding form of complexity between the repair innovation aspects of society and the collapse form. The idea of a collapse form originates with Paolo Rigolini in a personal conversation with me in the last few days. These two forms directly compete with one another, the complexity and the collapse. And the critical events are those that prevent or repel the collapse. It is my own sense that the collapse functions have not yet been comprised as in a mathematical taxonomy or implementation in physical natural law equations. I could be wrong about that. Yet they are essential to understanding complexity and critical events. Now the idea of our continuing with critical events versus harm to society. From a modeling standpoint, the most difficult mathematical form may occur when the same predictor of good health at the societal level, for example, historically the manufacture of iron for building architecture, may result in health damage to laborers who are directly involved in mining or smelting of the iron. Thus, the decline in industrial societies and labor force devoted to manufacturing, our current decline in almost all industrial societies, will increase overall health because the manufacturing is disappearing in terms of the labor force, but decrease the health of those who labored in manufacturing and no longer have jobs, and their communities, but lost their jobs. This phenomenon of enhancement and damage is referred to in economics as creative destruction, a term originated with the American-German economist Alois Schumpeter in the 1950s, I believe. This decline in manufacturing and substitution by the services and knowledge industries have created radically increased economic inequality, promoted extreme right-wing populism, and authoritarianism, that is, non-democratic governments, in politically important countries in Western and non-Western societies. In other words, important and life-preserving innovations may, in the medium term, create life-enhancing complexities, but in the much longer term, create health-damaging consequences. Thus, health modeling may require wave-like measurements that promote health for some populations, some people, and damage for other groups. These sequences are numerically very important. Multiple versus singular causation. In health modeling, in epidemiological modeling, it is now clear that, as in probably all historical phenomena, there are no singular causes. This was the unfortunate 19th century error of the great infectious disease epidemiologist Robert Koch, a German epidemiologist, that a disease such as tuberculosis requires exposure to the TB bacillus and virtually nothing else. And in the absence of that bacillus, no TB infection will emerge. But in the era of chronic disease, epidemic and endemic phenomena, chronic disease, the reverse has been found to be true. The longer-term epidemiology of heart disease cohort studies showed multiple risk factors to be present. For example, hypertension, triglycerides, physical mobility or lack of physical mobility, diet, poverty, diabetes, and so on. Many infectious diseases, including tuberculosis, have been shown to be influenced by multiple risks, especially poverty. It is therefore clear that in addition to physiological damage, the extent of ill health or death to a population will depend on resources embedded in complexity, specifically crucial events that repair or prevent the extensiveness of physiological damage. That repair function will depend on societal resources, which can be represented overall by the GDP, the gross domestic product. Per capita, recessions, of course, have the opposite effect and sharply reduce employment, business income, and welfare resources, including healthcare expenditure. I'm going to skip my next slide and go directly to the model itself, given the problem of time limitation. If we can go to the, yes, thank you. If we go to the model itself, the prediction of cumulative excess deaths in total. Excess deaths, as you know, are now the standard rather than COVID mortality, even though this would be a model these days of COVID mortality, since so many other sources of mortality, including age, diabetes, cancer, heart disease, and so on, are often embedded in this same phenomenon. So the absolute counting of COVID is no longer used by professionals. So if we look at this table, this is a table of the prediction of cumulative excess deaths in 30 countries of the OECD, that is the industrialized countries of the world, based originally on NATO and developed into a research organization in Paris. It runs over 20 months, that is the COVID period, essentially from March 2020 to October 2021. The model is very strong and with a few variables is able to explain over 75% of the variation in excess deaths in 30 countries over these 20 months. What are the predictors? The GDP, one of the most important, with a negative sign, significant. The lag of employment in the ages 15 to 64, so that also shows a negative sign since it is beneficial, of course. Now the most important, which is the cumulative incidence of COVID-19 cases, very positive, very strong. Now the other side of the coin, which is the repair function. People fully vaccinated, highly significant with a negative sign. And now we have data on boosters, which are necessary because we know that the vaccinations worldwide have limited time span in terms of effectiveness and then wane. And such variables as the proportion of the population over age 65. And finally, a new variable that has been created by the pandemic and by attempts to mitigate the pandemic that has resulted in recession. This recession has been one of the largest in the history of the last century or two. What is this new variable? It is the consumer price index or inflation. And as we see, a very strong Z statistic, highly significant, and one of the most powerful influences. I myself would not have thought that inflation would be so strong, but when one considers the new papers looking at the effect of inflation on very poor groups, it begins to become plausible. Let's look at the next picture. This is the graph of that full relationship with roughly a 76% explanation of variance. What we're looking at is the correlation or pictorial relationship between the occasion of excess deaths themselves being predicted by the total model. And as we see with the red line cross-cutting in between, it is a highly predictive relationship, even though we're dealing with 5 or 6 models, variables only. That's the formal end of my talk. I simply want to emphasize that without introducing economic variables into our understanding of infectious disease and social variables, we will not have good predictive models of how excess deaths or COVID, or frankly, any other source of health or mortality occur. So it's an attempt to bring together in a multivariable concatenation of variables our understanding of a multivariate phenomenon. Thank you very much.